So thank you, Professor Petali, and thank you for the organization who like to invite me to take this lecture here this morning in this very nice city of Thessaloniki, and with a lot of people that I thank to be here listening also me this morning. Well, I shall speak about the organic material that I am able to find in archaeological and findings and in paintings. Particularly, I have prepared some examples of how mass spectrometric technique, mainly interfaced with the chromatographic technique, can help us to understand the composition of the material which artists used in the past or just in contemporary art. Indeed, whenever we are looking at these beautiful paintings like this Madonna, we think to the ability of a painter and the ability to mix pigments and other materials. But indeed, I have to say that very often we have to think not only about the pigment, but also on the material, organic material which bind pigments. Indeed, all these examples are made with different binders, and when we speak about the technique, we generally refer to the painting technique, which is given by the binder. So, for instance, if we have a tempera technique, we have to think about egg or about milk or about glue. And so, an oil painting in the past generally was made by linseed oil, so we define the technique like an oil painting and so on. So, what to do? The painting is a very complex material from a chemical point of view because it is very heterogeneous and at all the level that we are looking for. And it is constituted by several layers, paint layers and support and so on. And in each of these layers you can find different pigments, but also different organic material which bind pigments. So, what means to understand the chemical composition of such complicated painting and layering? It means that if we are able to understand the composition, we are able also to study the degradation of the material which compose the paint itself. And then, if we are able to understand at molecular level the composition of this material, we are able to clarify the painting technique, to choose proper restoration methods, and to develop particular preventive conservation. And at last but not least, we can also identify fakes and guarantee that the painting is authentic or not. We shall see. I have prepared some examples for that. Well, what to do in this field? At first, we need, as a scientist, to make some diagnosis. And as you know, we can have non-invasive methods and invasive methods. So when you are looking at painting, at first you have to use non-invasive methods, because in this case you can apply a lot of portable instrumentation. We can give you the information of the composition of the surface. Indeed, from the understanding of hyperspectral or multispectral imaging methods, and then with the punctual analysis with the spectroscopic methods, you can have information on both pigments, restoration materials, some binders, some varnishes, some degradation products, but these are limited only to the surface. And if you want to deepen your knowledge and to know the layering and the material used underlay under the surface, you have to pick up some teeny samples, very teeny samples, and by these samples you can use invasive methods, and first of all you have to make cross-sections and to analyze inside the cross-section by using several spectroscopic techniques, which are the pigments in each layer and which are the contaminants. And finally, if you want to understand the organic material, you have to destroy your microsamples, and so I am coming in this phase. The final step is to destroy the sample and to understand which kind of organic material is contained in this sample. For that, I have developed the so-called chromatographic MS approach, which means that on a tiny representative sample, I can apply more than one technique. And first of all, analytical pyrolysis, which is able to give us the thermal features of the sample by using the EGA technique, and then by using pyrolysis, multi-step, multi-shot techniques, I can have the fingerprint of all the material contained, both natural and synthetic ones. After that, I can decide if I want to deeper again my knowledge, and so to choose GSM techniques or HPL techniques in order to have more information on the organic material, particularly by CMS, that we can identify simultaneously proteinaceous material together with polysaccharides, resins, glycerolipids material, pitches, and so on. But if you wanted to understand the presence of dyes, as it was shown this morning for purple analysis, you have to use HPLC MS analysis. So I shall have some example for all of that. And first I start with contemporary art. Here we are in Triennale Design Museum in Milan, and there was the need to restore this sculpture, something like, I cannot define it. And this is the Contenitore Umano, and it was not well conserved, and particularly the inside and the outside of this sculpture made in polyurethane form had different conservation problems. So the restorers asked to us what is going on, what is the reaction inside, and at first we tried to make evolved gas analysis to see how was the behavior of the polyurethane form. And by this case, you can have a thermal behavior, and under the thermal curve, you can understand all the mass spectra which are generated by the volatile organic materials which are evolved in time in this technique. So we have taken very thin samples from the inside and outside of this sculpture, and so the inside was less degraded, and the outside was quite degraded. And you see the thermal behavior. In the first step, till 287, you have indeed the additives of the material, and there is no difference from outside and inside. But if you look for higher temperature, you see that you have a different behavior. More degraded is the form, more temperature you need to define the material. This means that you are studying a cross-linking process. So it means that your material is more cross-linked, and the polymeric network is regulated. For this reason, you have higher temperature, and this means that your material is more hard, and it is pigments. So it is losing some pieces, and this is the problem of the outside of this culture. But if you are looking at the chemical composition, you can understand from this mass spectra that you have a polyether base polyols, which is not striking because we know that this is a polyurethane form, but what is striking is the difference in temperature. And then, if you're looking at the first part of the thermogram, you don't see any kind of difference here, but you know that you are in presence of additives and plasticizer mainly. Well, you have some other information because from this thermogram, you know which are the temperature to use under pyrolysis condition. So we use the pyrolyzer, this kind of pyrolyzer, and connected with the chromatographic column and mass detector, and this is the results of the first part. So when we want to analyze only the additives and the plasticizer, we had a surprise because in the degraded form, the amount of plasticizer are very, very low. So this means that you lose something in the form, you lose the gluing activity of the form itself. And if you look on the other part of the thermogram, so it means if the pyrolysis temperature is 600 degrees, you find exactly the old monomers and all the culture of the diisocyanate and polyol precursor, which have been used to polymerize the form itself. So the main information is on the first part, when you see that you have no more plasticizer. So this is the cause, the main cause of the loss of the fragmentation and the loss of foam flakes that we have observed. And under this condition, this new knowledge, restorers decide to make a dry cleaning protocol and to glue all the layers in order to restitute some elasticity to the form itself. Well, this is just one example, and what to do now, we can go only there and to see the final results, which seems quite good for contemporary art. Well, what to do with GCMS and HPLCMS? Well, this is a project which is in collaboration with the Museum in Oslo, in Norway. And we are looking for the composition of the sketches and some paintings which Munch produced for the University of Oslo in the beginning of the last century. And we are able to analyze not only sketches but also a lot of tubes that are stored in this museum. So what to do in this case? Well, this is the GCMS analysis for one of the sample of the sketch wall new rays. And as you can see here, we have several molecules which let us know that we are in presence of a drying oil together with a fine resin. The fine resin is given from the oxidized alkylic acid that you can see on the chromatogram. And then if I make the ratios that are used to understand which is the origin of the drying oil, I find that yes, I am sure that I have a drying oil because I have a ratio of A on T of 1.3, which is high enough. But I have a P on S ratio of 2.5, which highlight or nut oil or poppyseed oil, but I am not sure about that because we are in a period of history where the artists began to use tubes. And what means to use painting tubes? That the industry used not very pure oils, but they used to mix oils. So together with linseed or nut or poppy seed oil, they put also some other material, some other liquids, some fats, some wax, and very, very often they used a mixture of oil. So this means that I cannot rely on the meaning of P on S ratio, and I need something else to understand, which is the origin of the oil itself. For this reason, we have developed a new procedure which is able to profile the triacylglycerol and diacylglycerol of each kind of oil which can be used in art. So we have analyzed so many oils, and we have a good database not only of fresh oils but also oxidized oil. And by this new procedure, we have analyzed the same sample, and we found this characteristic molecular partner with the markers of palm oil. Well, palm oil is a non-drying oil, but in the GCMS we have seen the presence of a drying oil, so it must be something else in this chromatogram. Indeed, if I am looking, I can see all the oxidized molecule of linseed oil, and so I can conclude that this sketch, which has a lot of problems for conservation because it is sticky, so it means that the restoration is very difficult, and I can say that in this case Munch used a very commercial, not very good material, which is under the name of Richard Woolman paint tube, which was used very often for students, and so it is not a very good material for conserving a painting. And so finally I can say that in this tube and in this particular sketch, it was used a mixture of palm oil and linseed oil, which explain the sticky aspect of this painting. Well, this is one of the findings that one can find and can give a new knowledge to the restorer in order to understand what to do, what kind of chemicals to use in the phase of restoration. But we have indeed to go on with our knowledge. This is another example, and here we are in Raleigh at the North Carolina Museum of Art, where there is this very nice collection of the Scott family, and these are English paintings of the period you can see in the 16th century and 17th century. And so we have analyzed all of them, and in all of them there is the presence of linseed oil, which is normal, I have to say, for the period of time and for the kind of artist that made these paintings. But what is interesting in this case is this pink color of a Scott dress, and so we analyzed one sample, and we used this kind of procedure by HPLC Institute of, and in this case we set up a procedure based on the extraction of the colorants by ADTA and dimethylchloramide, and then we obtained this kind of chromatogram. And looking at the peaks, we are able to understand the presence of carminic acid, fructulin, and glycerin, which is not so striking. So this means that we have a mixture of cochineal lake and mother lake. Well, but this is not enough. We would like to understand also the presence of some minor component, and so we saw the presence of a secondary component of dactylophilus costa of the cochineal lake, but this compound, the C2, it was present in quite high amount, more than 1.5% of the total cochineal present in this sample. So this means that this is not the cochineal coming from Europe, but this is the cochineal lake whose origin is from America. And this is an important information from the historical point of view, because it demonstrates that there was a trade just after 50 years after the discovery of America. So this is important, very important for historians. Well, I tried to put on the table another problem that is now very available in the market. What to do when we have to understand if a painting is a fake or is not fake. Well, obviously, we have to work together with a historian and a lot of other people in this field. But I wanted to show you this peculiar example. In this case, we have a portrait on a painting which is made on two sides of the canvas. And the painting on your left is on the back, and the portrait is on your right. Okay, and so this is a sketch of the very famous painting Dr. made by Vincent van Gogh just a few months before he died. And this painting has disappeared from the market, and a man came to me, and so the owner of this painting asked to me to make a lot of analysis to understand if this was a sketch made by Vincent van Gogh or not. Well, a lot of people worked in this on these paintings, and we understood that this was indeed a painting which was realized by using a tracing method from the original one. So it means that the original one that you see on the back was available to the painter in order to trace and to make the same proportion of the design. That looking at the chemistry of this painting, we have found, for instance, that the pink, which is very light, and it was not possible to understand its composition from a Raman spectroscopy. It was analyzed by HPLC, and we found that this is made by alizarin, synthetic alizarin, because in the commercial synthetic alizarin you can find these two markers, dihydroxy and tretinoin, which are not present in the natural one. So this was quite striking again, and then we found that in the orange sometimes there was some shade which was made by the orange P05, which is another synthetic compound, which was found at the end of the 19th century, but it was patented in 1909. Well, these two were quite. I began to have some doubts about the authenticity of the painting, even though the analysis of the binder showed us that we are in absence of proteins, but in presence of very oxidized drying oil, which seems to be linseed oil. And moreover, we found that together the binder, it was present in paraffin, and we know from the history that at the end of 19th century, the tubes were produced, which were produced in France, contained the paraffin together with the linseed oil. So we have a different indication to understand if this painting is made by Van Gogh or not by Van Gogh. But my feeling up to now is that this was not painted by Van Gogh because I found a synthetic alizarin, which had never been used by him, and then the presence of PO5, I think it was too early for him to use this kind of colorants. So I am sure that this is not, quite sure that this was not produced by Van Gogh, but by a painter who was very close to him and who had the chance to have in his hands the true portrait of Dr. Gachet. Well, so this is my history with this painting. When I told to the owner that this is not by Van Gogh, he had some problems. And you can imagine, he believed that he had some Van Gogh painting artism. Well, this is one of the stories which I can't tell you, but I wanted to say that we can work in this field and find so many interesting things. And now I like to present you what I am doing in these days. So I am trying a new research which is aimed to realize how to deal with a portable mass spectrometer and to bring a portable mass spectrometer inside the museum in order to make in situ measurements. Well, in this case, we can have information on volatile organic compounds, and so we can quantitate and identify them indirectly in the museum. Obviously, we had to validate the procedure in the lab so that we have tried and we have that data for synthetic resin and natural resin on specimen made in the lab, and so we have preliminarily characterized them by SPME, GCNS, and then after acquisition by SIFT-MS, we had the opportunity to understand which are the volatile markers which can identify and recognize a specific material which is contained in a closed chamber. Indeed, we used a chamber like this with the sample inside, and for a settled time, we acquired at first with the fiber, the volatile compound, and we analyzed them in GCMS. After that, we used the probe of this portable mass spectrometer, and we acquired simultaneously 3 different reagent ions, so we have for each compound 3 mass spectra to understand. So the complexity of the problem is enough high, but now we have this big database of references, and we can approach for this problem also in museums. Indeed, we are analyzing objects in the museum, Egyptian Museum in Turin, and we made the first measurements on the last July, and the next week we shall be there again to understand something more. You see here the museum at the tomb of Ka and Merit, which is one of the most beautiful things contained there. And And we have put envelopes on the materials that we wanted to analyze. So we left for some days under exhibition our envelope, the materials, envelope, the amphora, and so on. And you can see here again. So these are some fluids, something I don't remember what is. And we'll again some other amphora, and here again we have a lot of materials analyzed, and you can see here ongoing research activities. And so this is a way how to explain to the public what we are doing. And so we are not something on the air. Indeed, we are working with you, and we have to work all together. And this is the instrument which was put just in a room close to the exhibition area. And this is television, because they were so curious about what we are doing. And finally, we transport everything, and we put the probe inside the envelope. You see here the probe which is put in really inside. So we are testing the head space of this object. And this is Jacopo Lanasa, one of my researchers, working hardly on the subject. Again, the acquisition of the volatile organic compound. Some example again. And she has Erika Bikini, a professor working with me. And in some cases, it's possible simply to open the amphora, to put the probe, and to analyze for 60 seconds what is the air inside, and to obtain the result. And again, another example, and they are working, so Francesca Modugno and Ilaria Degano working with me in my research group. And they say, please don't disturb, I was making photos. And there is another lady here, what are they doing? We don't understand anything, indeed. It's a very difficult matter, but we are approaching to some good solution, and I have no solution for you now, because all the results are under progress, and so I hope to have explained to you that we can work a lot in this field, and we can have so much information also, even if we don't pick up a sample. But finally, if I want to be sure that what is contained in a vessel or in a painting, finally, almost one sample has to be sacrificed, and HPLC and GCMS and Pros-Eleusis GCMS have to be applied to be certain about our results. So I hope to have shown you how to use in some way these techniques, and which kind of information we can have, and how we can implement our knowledge and the knowledge of historians and of restorers. And sometimes we are able really to help in this field. And then I wanted to inform you that I am also the director of a summer school of the University of Pisa. In the next year, in September, I shall organize a summer school for master and PhD students and who want to attend this kind of school with the focus on paintings. Well, I have to thank you for your attention, and I thank you again, Antigone. And if you have a question, please let me know.